Hello and welcome to our talk about discovering headmates' functions or anatomy. My name is Yuki and I'll be presenting with Hanami. We're part of the Smash System, which is 17 headmates strong. We have a linguistic and scientific background. In the science field, we have done research in cancer and neurobiology as part of a master's degree, and today we want to share with you our knowledge about the brain. All names mentioned during this presentation are for explanatory purposes and do not reflect system members nor the entirety of it. In this talk, we will give you tools on how to understand your system and your fellow headmates better, with the help of anatomical placement. Let's get started.
The most basic tool to begin with is to record the skills you are already aware of, and to keep recording those as you learn more about each other. It can be done in a notebook or with a worksheet that guides you through the process. Most will have a setup as you see in the table. They're listing the name of the headmate, their activity or role they have in that task, and what skill is required. As you can see, Dave participates in 2 different activities that are related to the body. That already gives us the first few clues to him being a physical headmate who mostly takes the body. Eva, on the other hand, has the smell and is only involved in one part of the cooking process. You may find that some headmates have very specialized tasks that they execute briefly and thus can easily go unnoticed. Aside from Dave and Eva, Sally is also involved in the cooking process, yet her role is not mentioned since it isn't clear so far. If you notice multiple of you are participating in an activity, but each of your roles aren't clear, then you can investigate their skills with the methods I will present later on. These can help you understand what part a headmate plays in an activity. The same applies to Bob, as he is clearly involved in admin, but only Chloe's skill is apparent. Over time, the skill of another headmate may become more obvious as you learn to distinguish each other. However, there are tools that can expedite this process a bit, like investigating their senses. What do you see? What do you hear? What do you feel? What object is it? What do you smell? And what do you taste? Probably most of you already are familiar with these questions as a grounding or stabilizing tool. In that case, the point of the exercise is to make contact with your surroundings. But did you know you can also use these questions to get to know your headmate's functions under stable circumstances and be ahead of the game with grounding in challenging situations. By understanding what senses they have, you know what tools and questions to ask when a headmate is having a tough time. I will demonstrate a few of these and will be using various objects for the test. You're welcome to join the demonstration and have your headmates participate. If you at any point feel uncomfortable by the exercise, you can stop participating and do the exercises at a later point when everybody feels safe and ready to do so. To get the most out of the exercise, I recommend to ask a question, wait for the answer, and then to ask for the headmate's name that answered. You can do this outwardly or internally. In some cases, you might get someone else identifying themselves during the exercise, so it is good to have them recall it at a later time point for validating who actually stores that information. Let's get started. What do you see? Blue eyes, pink nose. What do you feel? Sequence. What object is it? Fishbone. And the last one, what do you smell? Sumac. After completing the exercise, you can write down your findings as shown on this table. These are just some general examples of what kind of answers you can get, aside from what I just demonstrated. To get a clear record of who has what perception, I recommend asking a loved one or a friend to help you by handing you an object. Make sure to agree on safe objects before starting. This way, you don't have headmates with different visual capacities giving away the object. As you can see, there are also different types of vision. In general, we distinguish 4 types: distance and spectral, mid-range view, near and hyperfocus, and the last is facial recognition. Some headmates that have a different range of vision can co-friend and thus give the object already away, before the headmate with a closer range actually has it in their view. Hence, it is also good to discuss what perception and at what range you want to test before getting started. You may find that depending on the object you get handed, different headmates may describe the same type of details. This is because you can have function overlap, so that one can compensate for the other when they are not allowed to co-friend with a certain headmate, which is busy with a task that requires a co-headmate with the same skill as the one they cannot co-friend with. In the following section, I will be referring to trauma memory in general, though nothing will be explicitly named or described. Normal memories will have more detailed examples. The distinction between normal and traumatic memories is made by scientists based on how these are stored in the brain. You are welcome to join again after the following section, should you not feel ready for this type of content. Please ensure your safety first. You can determine what type of memory a headmate has based on their recollection. This can be for normal, happy memories, but also for traumatic memories that resurface during flashbacks. In the table you can see that for some headmates, traumatic memories have resurfaced, but normal memories haven't yet, and vice versa for others. This is dependent on the environment you're in, and what memories get reactivated by those conditions. This applies to good and bad. In Bob's case, the negative memories are better known, and he mostly hears conversations and reliving the past stress. This can be in whole sentences or sentence fragments, or only a word. However, from this we can also assume that he will store regular conversations as well, and may help other headmates recollect what has been said in the last conversation with a friend, for example. One may just not be aware of who that helping ear in this case usually is. Max, on the other hand, has recollection of both negative and positive memories related to the surrounding. This can be, for example, from a nice day out, remembering the beach, seeing the tide moving in and out, or noticing flocks of seagulls in the distance. This tells us he has spatial and distance vision, but not narrow or hyperfocus, since then he should be able to remember details such as little crabs on the beach, which isn't the case. In some instances, only the positive memories are known, as it is for Lisa. That doesn't exclude her from potentially having distressing memories. If you have a case like this, then the positive memories can give you a hint at what to expect and how to make contact with the environment for stabilization should distressing memories resurface. So what can we learn from Lisa's memories? From studying a lot, she retained the Chinese characters, and she can recognize them upon seeing them and understand them. This means she has part of the language, but only in written form. It doesn't tell us anything about if she's capable of understanding the language. That is more likely to be Bob, as he has the hearing. So you can see by the different types of memories how multiple headmates might be needed to acquire a new skill, such as becoming fluent in a foreign language. And what about those headmates who can't remember anything and are always struggling to recall the simplest things, like this morning's breakfast? The thing with them is they can recall, but only short term, and have for anything further in the past amnesia. You might find that your hosts have long-term amnesia, yet function fine in day-to-day life. That is because their short-term memory is sufficient to adapt and cope with the current situation, so the past can be left in the past, somewhere neatly stored with someone else. Recognizing headmates by headaches is a tool that is especially helpful for new systems, as most plurals experience a lot of headaches in the beginning. Systems that have already settled may only have them occasionally or during tough periods, but it remains useful for both to get a rough idea of a headmate's skills. I also want to emphasize here that this is the least accurate method, as it only gives you the surface area and not the depth. Different brain structures and functions sit on the outer and inner layers of the brain, so be aware that you may have to revise your initial assumptions later on as you get to know headmates better. Since we don't always have a good estimate of how the brain is positioned within the skull, and we might misplace headmates if we try to transfer our personal experience to a brain model, I have used a black head here with a brain outline in it for guidance. This way, it is easier to color the regions where you feel headaches, as shown in this example. As you can see, Hannah gives headaches in the front and Max in the back, so they will have functions related to those and the surrounding areas. Headmates are not always aware of causing headaches and trying to front. It is a physiological response to them not being able to surface, so try to give them the space to interact with you and the environment. Please also be aware that headmates do not always give headaches in all regions of the brain they fire in. Other functions may need to be discovered through other methods for this reason. It is also possible that you may experience headaches at the intersections where two headmates connect. This is because they might have a combined skill, such as reading and organizing information together. Now that we've collected a lot of data on our headmates, let's have a look at what sits around the brain and how this equates to them. We will start at the back of the brain with the more primitive functions and will slowly move our way forward to the higher functions. Important to know, we are looking here primarily at the outer cortex of the brain and only a few inner structures that hold emotion and memory consolidation. This image is a guide for understanding the basics of brain anatomy, but does not represent the entirety nor the full complexity of the brain and its regions. At the base of the brain lies the brainstem. This controls breathing and the heart rate. No particular headmate will have control over these, as they are basic automated functions that need to be active at all times for the body's survival. Next is movement coordination. This is about keeping your balance, and this will be accessed primarily by physical headmates. In the examples mentioned previously, Dave was one to sport, so you would have some control over this to not fall over while balancing, for example. You can even test your headmates as to who has better coordination by walking across the beam, for example. On top of it sits the vision. Now most headmates will have a part of that, but to test what type, I recommend doing the perception test. Adjacent to those structures are taste and hearing, so those headmates always craving a snack will have a part of the taste center. Behind it and linked to the hearing is one of the language centers known as Wernicke's area, which is relevant for language comprehension, written and spoken. Thus it makes sense that those who have the hearing will have a part of that language center as well to understand what is said. I want to emphasize that this is only comprehension, but not production. The language production, such as writing, speech, and grammar usage, sit further to the front, close to the speech center. This language area is called Broca's area and is relevant in language production, such as constructing sentences, especially in spoken but also in written language, as you need to continuously apply correct grammar. Close to these areas is the smell, where Eva, for example, will lie as she evaluates how well the dish got spiced by smelling it. Above the described regions sits the motor cortex for movement and the sensory cortex for touch. To understand both better, especially where they border, as marked with an A, it is good to have a look at the homunculus to the right. The homunculus equates body control and perception to body parts. The most inner regions control the feet and legs. As you move upward, you reach the hip and the trunk. Headmates that have overall body control will sit more in this area, and the experienced headaches feel as if they sit at the midline of the brain. As you slowly move along the side of the brain, you have hand dexterity, think of Lisa here, with executing calligraphy, for example. This is followed by the face, so if you have any lobes making funny faces, you know where they live in the brain now. Last but not least are the tongue and larynx. These areas are most likely controlled by headmates that eat, and will frequently have part of the taste as well. However, just because a headmate has muscle control of her body part does not mean they also get all sensory information from it as well. It is very possible that the motor and sensory border is also a border between headmates to ensure survival while the devastating events get encoded into the brain. You may also find that some headmates only receive part of the sensory information. That is to protect them so that they wouldn't get overwhelmed during extreme events. Slowly moving forward, we reach the higher functions, to which speech production and its required muscle control belongs. Adjacent to those regions are those parts of the brain that we refer to as the logical part of the brain, which makes decisions in the lower part. To this belongs also evaluating options. So if you have an indecisive ruminator, they'll be located around here. Does anybody else have headmates who love color-coding agendas and planning everything to the minute? They hold the neighboring region, and it might not be uncommon to have a headmate holding both decision-making and planning part of the brain, as it helps them to execute things in a more coordinated way. And the last region, all the way at the upper front, is the attention center. That's where a headmate with constant amnesia sits. They're very focused at the task at hand, but will feel like they lost time after the joy of acquisition is over, just like in the example with Chloe, who has long-term amnesia. In this diagram, parts of the inner structure have been outlined in the lower green section, where it says memory processing and emotion. I will not delve too deep into these two, as they play a big role in how we recall positive and negative events, and have a complex interplay between each other. Though as a general guide, the more reactive or social a headmate is, the more emotion they hold. Now, after getting an idea of the basic functions of the brain based on a few examples, I want to expand on it here a bit further. In the table, I have listed different functions on which brain part coordinates all of these various functions. As previously mentioned, the motor cortex enables you to write by hand, but it also is relevant in handcrafts, such as guiding a fabric through the machine, as well as folding and gluing items together. Essentially, anything that your hands do is controlled by that region shown in the motor cortex. When it comes to feeling the items, however, that would be in the neighboring sensory cortex, as you know now. Let's have a look at the second one. Where is hearing involved? It's not only relevant for learning a new language, as mentioned. Any listen content, from educational videos and podcasts, just like this presentation, goes through the auditory cortex and the adjacent Wernicke's area that helps you understand the content. Another one I've already touched on is the evaluation process in the decision-making part of the brain. This is also where you prioritize and set up to-do lists. And what is the attention center known for? Aside from leaving a headmate with long-term amnesia, it's basically where your curiosity sits, and the drive to discover and acquire novel information. Essentially, if the system wants to learn something new, you have to send out the most forgetful one to learn something new to benefit the rest. It may seem paradoxical, but your attention center is only active for new cues. Old ones it overlooks and keeps on searching until it finds something unfamiliar to pass on for storage. I hope with these examples I could give a few ideas to help you discover in your own lives what tasks you do and how they relate to different memory types and how to expand your skill set by knowing the memory type a headmate has.
We have come to an end of this journey, and I hope here begins your journey of discovering and understanding your plurality better. Thank you for joining, and I look forward to answering any questions you may have.